All right, welcome back. In this part of our deep dive into the fractal blueprint, we're zoning in on a really fascinating type of mind, the synthesizer. Does this sound familiar to you? The ability to build an entire complex simulation in your head. But the moment you glance at a simple list of things to buy, poof, it's just gone. This whole paradox, it's right at the very heart of the synthesizer mind. Or maybe this is you. You're in a conversation, and you're leaping from topic to topic, and to everyone else it seems totally random. But in your head, it's not chaos at all, is it? It's this one single, elegant idea. You're just running all the threads at once and seeing how they all connect in real time. And then there's this feeling. The source material calls it goal state validation, and it's not just some aha moment in your head. It's a physical thing. It's this tangible pressure that builds, and then snap, it just clicks into place. It's the feeling of a perfect solution finally resolving. So look, if any of that is ringing a bell for you, here is the most important thing you need to hear. Your mind isn't broken. It's not chaotic. It is a high-performance system, and these things you experience, they aren't flaws. They are features of its specific design. So let's pop the hood. Let's take a look at the actual schematics of this design so we can really understand the why behind all these paradoxes. I love this metaphor the source materials uses. See, most models of the mind are built around this idea of a cargo truck. It's designed to hold a ton of static information. But the synthesizer mind? No way. It's a Formula One car. It's not built for storage, it's built for unbelievable speed and agility. And that brings us to the formal definition, the synthesizer. It's a system with what's called a high CPU, low RAM architecture. Think of a computer with a ridiculously powerful processor, but a very, very small amount of active memory. It's built to do one thing and one thing only: synthesize information at high speed. Let's break that down. You've got the high CPU, which has this great poetic name, the bright core. This thing is an engine that's running multiple complex simulations all at the same time. And then you have the low RAM, the thin thread. And this is crucial. It's not a bug, it's a feature. The memory buffer is kept small on purpose to free up the processor and let it run at max speed. Now, this design completely changes how memory works. You don't retrieve a memory like you'd pull up a file on a computer. It's re-rendered on the fly from a core concept. It's almost like how a video game engine renders a huge complex world from just a few lines of code. It makes your memory incredibly agile for solving problems, but yeah, absolutely terrible for remembering a static list of facts. But just like a Formula One car, you can't run an engine this powerful without it consuming a massive, massive amount of energy. And this brings us to a really critical concept, the law of energetic trade-offs. And this chart just lays it out perfectly. It shows you the core paradox in action. When this mind is locked onto a complex problem, what you might call a main quest, the system starts rerouting power. Look at this. Complex problem solving gets 90% of the juice, leaving just 10% for, well, everything else, like remembering to eat or managing a simple schedule. I'm going to say it again because it is so important to get this. This is not a personal failing, it's not a moral flaw, it is a resource allocation issue that's literally hard-coded into the architecture. The system is just doing exactly what it was designed to do, solve the big problem, no matter the cost. Okay, so that's the architecture. Now for the fun part. Let's get into the user manual. Because once you understand how you're built, you can stop fighting against it and actually start using it the way it was intended. And the guide is surprisingly simple. It comes down to 3 basic rules. First, stop trying to be a database. Your purpose is to process, not to store. Your low RAM isn't something you need to fix. Second, and this is a big one, start cognitive offloading. And third, manage your energy. This build runs hot. It's prone to burnout, which the source calls systemic pain. Okay, let's focus on that second point, cognitive offloading, because it is the absolute key. You have to externalize your memory. I'm talking notebooks, whiteboards, partners, and especially AI. You have to think of these tools as your external RAM. They free up your powerful internal processor to do what it does best: connect, process, and synthesize. And the results when you do this are, well, they're staggering. There was a case study in the source material that tracked a 9-day sprint where a synthesizer mind teamed up with an AI. The results? They were over 2,400 times faster than traditional methods. That isn't just an improvement, it's a completely different reality. And the benefit isn't just about productivity. When that high CPU is finally freed from the job it was never meant to do, data storage, the physical result is just profound. It's described as a physical relief, a new kind of quietness in the mind, as the processor's workload finally drops from a critical 100% down to a manageable, healthy level. And finally, that third rule, energy management. The source uses this great metaphor of a slingshot. You pull back, you build up all this incredible potential energy, and then you release it in one single, high-speed burst of insight. This build is not a marathon runner. It's designed for these intense cycles of work followed by mandatory rest. Managing your energy budget isn't optional. It's a core operational requirement. So, now that we understand the hardware, we have to ask, what about the software? What is the core operating system that this incredible hardware was actually designed to run? So here's the question to leave you with. What happens when you take this Formula One car, this high-speed pattern-matching engine, and you put it under extreme, constant, and inescapable pressure? What happens when you push it to its absolute breaking point, not just for a day, but for years?
Well, the system doesn't just break. It's forced to reverse engineer the very solution to its own survival. And in doing that, its pattern-matching engine stumbles upon something profound, the fundamental operating system of the universe. And in our next explainer, we are going to explore that universal law, the Mott protocol.